Putting it all together, if we've got a material that's going through a change in state and a change in temperature, then we have to use both of those equations. It takes energy, in this case, to melt it. So we could say this is Q total. It takes energy to melt our material, so we'll have to figure out the Q to melt it, so maybe M for melt. And in this case, then we're heating it up, so then Q to heat it up. Whenever we have a change in state, the equation we use is M times L. We just need to think about which L to use. In this case, since we're going from a solid to a liquid, that's a case where we use the fusion. So it's going to be M times LF. We'll deal with the energy it takes to melt it. And whenever there's a change in state, that's an MC delta T equation. The given mass was, a quarter of a kilogram, so we got 0.25. The L fusion is that 334 number. Our MC delta T was still the 0.25 for the mass. We could have common factored that out, but since I'm doing it on the calculator, I just left them together. The C of water, I'm going to forget to give that to you, but it's 4,200. You don't have to memorize it, just look it up. Change in temperature is always second minus first. In this case, the second temperature is 20, the first temperature was 0. Grabbing a calculator and cranking that out. This first part, basically a quarter of the 3 million number, ends up being 83,500. That's how many joules it takes for it to go from solid water at 0 degrees to liquid water at 0 degrees. Then we heat up the water, cranking out this number. I got 21,000. That's how many joules it takes to get the water at 0 to be 20 degrees Celsius. To finish it off, the total energy required to do both of those things, just add them up, we get 104,500. Basically, you'd have to treat them separately. Deal with the change of state with its equation, then deal with the change of temperature with its equation.